Barbiturates are another type of depressant. Things like Xanax or Valium, you might have heard. These are drugs that are often prescribed for sleep or for anxiety, and they are widespread use. Benzodiazepines are creating an increase in the number of deaths in this country. More and more emergency room cases and overdoses are occurring because of them, mostly because they are being mixed with alcohol. And it turns out that a safe dose of alcohol and a safe dose of benzodiazepines, when combined together, quickly become deadly and often take people by surprise. To understand this sort of effect of deadliness of drugs, we need to talk about those dose-response curves that we first saw when we talked about tolerance. There are 3 dose-response curves that we want to pay attention to: the therapeutic effect, the toxic effect, and the lethal effect. The therapeutic effect represents the amount of the drug that you have to give somebody to have a therapeutic response, what you are looking for. The toxic dose curve represents the percentage of people who will have a toxic effect at that dose, and the lethal effect represents the percentage of people who will die at that dose. So if you look, for example, at the therapeutic effect, you might find a dose where, about 80% of the people will show a therapeutic effect. That means 20% of the people will show no effect. The drug will not help them. So why don't we just push it all the way to 100? Why don't we give the dose of which we know 100% of the people will have a therapeutic effect? Well, if you follow this graph, you'll see at 100% therapeutic effect, 25% of the people will have a toxic effect. So we tend to talk about what we call the ED50, the TD50, and the LD50. The effective dose, 50%, is the dose at which half the people should show a therapeutic effect. That's considered a relatively safe dose most of the time. The TD50 is when half the people are going to demonstrate a toxic effect. That's considered a very dangerous dose. And the lethal effect, the LD50, is when half the people who take the drug at that level will die. That's usually considered the lethal dose of a drug. Half the people who take the drug at that dose will survive, but LD50 is usually considered the point at which lethality begins to overwhelm. All right. So when we're talking about drugs, the ratio of the LD50 to the ED50 becomes very important. Almost anything you put into your body has an LD50. Right? It's just oftentimes we don't run into it because the difference between the effective dose, what we're looking for, and the LD50 dose is so big. But anything can have it. For example, water. The LD50 dose for water is about 6 liters in a sitting. If you were to chug 6 liters of water right now, please don't ever do that. But about half of the people listening to this right now would not survive that activity. Unfortunately, there are many people that die from water. Unfortunately, there are people who die every year from water overdoses. They're often associated with dares, hazings, or other activities where they're drinking more water than they usually would, but it does kill people. Most people, though, the effective dose of water that we need is so small compared to this, that's not a problem. 118 cups of coffee creates an LD50, 13 shots of alcohol. So you can see that the amount that it takes decreases pretty rapidly, and by the time we're in the alcohol range, 13 shots is a lot of alcohol in a sitting, but it's something that people can do, and why people die from alcohol all the time, and certainly way more than caffeine or water. In fact, if we look at that ratio of how big of a difference there is between the LD50 and the ED50, that really tells us the safety of the drug. So if we look at a variety of drugs that you might find, recreational use of, and we look at that ratio, that can really tell us the safety. So, for example, we can see up here, so the bigger this bar graph is, that means the bigger the difference there is between the ED50 and the LD50, the safer the drug. So marijuana, LSD, psilocybin. Psilocybin is found in magic mushrooms. These are drugs that it takes a whole lot of the substance to kill you. And since you really only need a tiny amount of the substance, for example, LSD is measured in micrograms. the safety is pretty high, right? So even though it doesn't take a lot of LSD to kill you, a few grams can do it. The fact is that people are taking it in 1/1,000,000th of a gram, so therefore that difference is pretty huge. It starts to drop off pretty dramatically, and we can see that things like intranasal use of cocaine, alcohol, heroin, particularly intravenous heroin, can become quite unsafe. So the intranasal or intravenous or oral here are important, also inhaled, which tells you that the way in which you consume the drug can have a dramatic effect on its lethality. Right? This has to do with bioavailability. How much of the drug is likely going to be available to the nervous system by the time it reaches it? If you consume a drug orally, that's going to have some of the lowest bioavailability of any route because the digestive system breaks it down. Inhaling the drug increases the bioavailability, causing it to respond faster, and also more of the drug to be present and dramatically increasing the risks. Intranasally, which is, snorting it through the nose or putting it on any mucous membrane, for example, rubbing it on gums, anything along those lines where you're absorbing it into the body, also increases bioavailability and risk. And probably the highest bioavailability is when you're injecting it directly in your veins, like many people do with heroin, which takes an already dangerous drug and makes it that much more risky because almost the whole substance becomes bioavailable. You may be looking next to the heroin there at nutmeg and beginning to worry about those pumpkin spice lattes and whether or not you should be putting nutmeg on them. Well, this brings up another important point. Remember, this is the ratio, the difference between the effective dose and the lethal dose. And something like LSD, right, where you only need a tiny amount of the drug to kill you, but a correspondingly even smaller amount to get the desired effect, it's relatively safe. Nutmeg is dangerous not because a small amount can kill you, but rather the dose at which nutmeg is hallucinogenic, which is why it's sometimes used as a recreational drug, is really large. People consume large quantities of nutmeg to get that high, and it turns out that at the level at which the drug produces the high is super close to the dosage at which can kill people. All right, so a little bit of sprinkle of nutmeg on your pie or your coffee is not even remotely dangerous. It's only when it's consumed in large quantities by people trying to get a high effect from it that they start approaching that lethal dose. All right, so it's about the ratio of the LD50 to ED50 and not the absolute measurement of the LD50. Where things get particularly dangerous, though, is when we start combining drugs, particularly drugs that have a similar action but work off of a different mechanism. And as I mentioned, benzodiazepines and alcohol become a very dangerous mix because they both affect the same ionotropic receptor. Whereas ethanol attaches to the alpha protein, the benzodiazepine connects to the gamma protein. This means that the combination of benzodiazepines and alcohol is not additive, right? You're not taking 2 shots plus 2 Xanax. It's actually multiplicative. It's dramatic. It's exponential. So even though you have a safe dose of benzodiazepines you normally take and a safe dose of alcohol, if you just cut them in half and combine them, you're not going to get the same response. You're actually going to get double the response, which is why people who combine these often find themselves overwhelmed and wind up dying. The last depressant I want to talk about is opiates. Opiates come from the opiate poppy. Almost all opiates are found either directly within the opium poppy or derived from chemicals that are found in the opium poppy. They are many different ones that have been found. Heroin, morphine, hydrocodone, hydrocodone, oxycodone. There are many, many drugs that have been pulled out of the opium poppy. It is a drug that has been very effective at pain treatment, which is why it is still widely available and often prescribed, but is also highly, highly addictive. The opioid receptor is actually a metabotropic receptor. The mu-opioid receptor, which is the primary binding point for opiates, is a metabotropic receptor, not an ionotropic. So rather than opening up a channel allowing ions in, it instead releases the G protein that goes through and actually opens up potassium channels. So what would be the effect of opening potassium channels? Well, when the potassium channels open, the potassium is going to leak out, but in what direction? Well, remember how this works. 3 sodium out, 2 potassium in. So the potassium is located inside the neuron, and as the potassium leaks out, it actually makes it harder for the action potential to fire. So the neuron is less likely to fire, thus creating the depressant effect. In fact, this is why it decreases pain, because it actually binds to the mu-opioid receptors on these pain cells, releases the potassium that's stored in them, making it much harder for these pain neurons to fire. Thus, the pain neurons are unable to communicate the presence of pain. Opiates are a crisis right now. The amount of overdoses and deaths are tremendous. And in fact, the use of Narcan is now widespread, with almost all first responders, police officers, and almost anybody should probably be walking around with Narcan because it can instantly save a life. Narcan actually binds to the mu-opioid receptor, but it doesn't attach. So it doesn't activate the receptor, but instead blocks the opiate from attaching, almost instantly reducing the overdose and causing the person to almost immediately come back to sobriety. In fact, I'd like to break down the opioid crisis just a little bit. If we look at the opioid crisis, what you'll find is that the number of deaths from it has been exponentially increasing. It was driven a large part by pain relievers. But around 2011, 2012, we began to worry as a medical community, as a society, as a country, about the increase in opiate deaths and its correlation with prescriptions. So they stopped prescribing the drug. People weren't suddenly able to just stop taking opiates because their doctor would no longer prescribe them, right? Go back to our tolerance, withdrawal, addiction cycle, right? So people taking opiates are going to develop a tolerance, right? Which means that those pain neurons that were being blocked before, since their activity was being decreased, are actually going to become more sensitive. So if you suddenly stop the presence of the opiate, the person is now going to experience much more pain than they were experiencing even before they started taking the drug, right? Body-wide, horrific, terrible, gut-wrenching pain. This is a horrible situation that leads to strong physical dependency, a strong drive to take the drug, where your whole entire body is racking in horrible pain, and the only way you can feel better is to take that drug. And if your doctor's not prescribing it, where did they turn? Well, they started turning to heroin. And heroin turns out to be a lot riskier, right? And we see those overdose increase. So what do? Well, they went after the heroin. And they tried to shut down the heroin. And that worked to some degree. But then we started to see massive imports of fentanyl into this country. Once they started attacking heroin, they started pushing fentanyl, because it was much easier to get fentanyl into the country. The law enforcement punishment for detecting fentanyl became less, and suddenly they were replacing people's heroin with fentanyl. And they weren't telling them. This is where we see a tremendous uptick in opiate deaths, because fentanyl, well, let's look at it. What you're looking at here is the LD50 dose for intravenous heroin compared to the LD dose of fentanyl. The LD50 dose of fentanyl. Tiny, tiny doses of fentanyl are enough to kill you. So by mixing the fentanyl now into people's heroin or treating fentanyl as the opiate, people have no idea what they're taking, and it's killing.